Okay, yeah. So I'll be presenting a new function for doing shell calls. So it's a new system function called quad shell, and we plan to introduce this in version 20. And I did a presentation on it last year as well, but we have changed a bit since then. So if you're afraid that you are just watching the same thing again, you won't be. And so the main improvement is that we are going to allow the user to control a lot of things about the execution environment of the child process that quad SH and quad CMD doesn't allow us to do. Yeah, last year I sort of went into the why we want to do this, and this year I'll be focusing more of how it actually looks, the system function. And so, first of all, why do we need to provide an alternative? And the short version is that quad SH just makes too many choices for us, really. And if we disagree with these choices, there's not much we can do. There's no ways to configure them. So for example, quad SH always just runs the child process and picks up standard output and converts that into lines of text. And then it doesn't do anything with standard error, for example. And it assumes that if the child process exits with a non-zero exit code, then that's bad and it gives a domain error. But that's problematic because maybe it produced some output before that, and we want to look at that to see what went wrong, really. And the last one is, I think is very important. Quad SH blocks all other APL threads while it waits for the child process to run. So it's really not that it's not that easy to run something that takes a while with quad SH. You can't do other stuff in your APL session in the meantime. Maybe we could have extended quad SH, but it's easier just to have a new system function. Then you can continue using quad SH without any worrying about any changes. And so, just to give an overview, it's a monadic system function just like quad SH. It takes a command as its right argument, and there are two ways to specify this command. One is just as a character vector, and that's the contents of that would be run by the system shell. So that's bin sh on all the non-Windows systems, and PowerShell I think we chose for Windows. And you can change this if you want. Or in many cases you just want to run a single program, and we decided that if you give it a nested character vector, it will run that first part as the command and then give the rest as the arguments. And you could do that as one character vector, but you need to quote the arguments yourself depending on which shell you're using. And there's also the benefit of the second way that it doesn't spin up the shell first, so that it might be a little bit faster. And then quad shell has a lot of variant options that allows us to change the default settings. And the result is a bit more complicated. It's this 5-element nested vector, and I'll go through it in the next slide. But even though it's more complicated, the common case is just to take the first part of this, and that will give you the lines of text that produced on the standard output. So it's not that dangerous. So let's have a look at the. Sorry? Yeah, first. So the first element of the stream data part of the result. And so the stream data and the stream IDs, they're both vectors of the same length. And that's because quad shell can collect output from the different streams, so standard error, standard output. And each stream has a number, and that will be in the stream IDs vector. And then at the corresponding position in the stream data, you'll have the data that was actually picked up. And so by default, the thing we do is that we redirect standard error to be merged together with standard output, and then just collect standard output, so we get both as one. Then we have some information about the reason the quad shell call stopped. And 4 reasons that quad shell can stop, and one of the 2 first are sort of the normal ones. So the child process might have finished, and then in that case we have the exit code as part of the result. And then the child process might have finished, but not by under normal circumstances. It might have been terminated by some signal, and then the exit code represents the signal number. And then we have these 2 down here where quad shell itself timed out, and I'll get into that, or that the user interrupted the quad shell call. So in the last two cases there, where quad shell timed out or the user interrupted it, the child process might still be running in the background. And then we might have to do some cleanup afterwards, so that's why we include the process ID as part of the result. And in the other two cases where the child process did finish, the PID field of the result will just be -1 or something. Yeah, and we plan to have an IBM to help you with doing some of the cleanup. And then I was planning to do a demo, but it didn't go that well, so I just took screenshots. I took screenshots of everything, so now I'm sure that it will work. So this is on Linux on the right, and the thing I'm trying to do is just use this Unicode program that I have that can tell me something about some Unicode symbol. So I'll ask it about the Unicode symbol called APL functional symbol omega, and it gives me this, and this is just quad SH, by the way. I'm just doing a comparison. So this isn't what I expected because I forgot to quote the argument. So I'll just do that with the double quotes because this is how I do it in that shell. And I get information about the two matching symbols, but something is wrong out here. It should have shown the real symbols, but quad SH doesn't do that. And if you use the result from quad SH, so quad SH has two modes depending on whether or not the result is used. So this is where it just prints it, and if you use the result, it gets you get the character vector, the nested character vector of the lines. But you still have the encoding issues. And so now I can do the exact same thing with quad shell, but then take the first of the first, and I get the two lines, but the encoding is correct. And I can avoid that quoting we put in by using this nested character vector form of the command, and it gives me exactly the same thing. It's just a preference. And we can have a look at the full result as well. And you can see it's this very nested thing, but at the end we have -1 for the process ID, and then 0, 0 means that the child process finished with an exit code of 0. And then the 1 is actually a vector, so we're only picking out standard output, and then the rest is the actual standard output data. And the Unicode utility has this option -I that allows us to specify a specific encoding. And so if I do this in quad SH, say that the output is UTF-32, quad SH doesn't really deal with that, and that's fine because quad shell will deal with that. It just looks at the output and sees what it looks like, the same way that quad NGet will try to deduce based on the data. But there's of course an option to specify that it should use a specific encoding. And here's another example. So I will try to list all the lines of text in some file that mentions Dyalog 24. And if I do that with quad SH, I use grep, I get no output. And then I might think that that's because I don't have any lines. But if I try to use the result, I get that domain error because it decides that it needs to check the exit code. So I see the exit code is 2, and I could probably look that up in some manual for grep and see what that means. Or I could use quad shell and I get the actual error message from standard error. Okay, so now we get back to the description. And quad shell has many variant options, but the typical usage, I think, won't require that much, if any, of the variant options. That will just be like what we saw before. And we tried to pick some sensible defaults, but let me know afterwards if you disagree with any of those. So the first one is this working dir. We can change the working directory. Otherwise, it just has the same working directory as the interpreter. And then we have this option to specify the environment variables. So every process has a set of environment variables, and by default it inherits the set from the interpreter. But we can say that it should start from sort of a clean state. And in addition to that, we can add additional environment variables or override some that already exists. For example, we can set an API key or provide some configurations option or whatever. And the format of that is a 2-column matrix of names and values, or a vector of name value pairs. Then we have an option to change the default shell. So for example, we use binsh on Linux, but you might want to use bash or something more exotic. And you can do that if you want, but it's only really relevant when the write argument is this simple character vector, because in the nested case it just runs the command directly and the shell isn't involved. So you can use bash or cmd.exe instead of PowerShell if you want to. And then you saw before that Quad-S8 has this check at the end that checks the exit code. Quad Shell doesn't do that, so that we can have a look at the result. But in some cases, it might just make your code easier if it's checked by default, so you don't have to write code to handle the error conditions. And you can enable that if you need to. But yeah, having it disabled makes it possible to actually deal with programs that produce non-zero exit codes, and it makes it much easier to figure out what went wrong when you can see the error messages. So we added a timeout variant option to Quad Shell, so that if you run some program that doesn't finish quickly, maybe it hangs or maybe it just takes a very long time and you don't want it to, it will stop the Quad Shell call, but it won't just produce a timeout error, it will just stop it, and the exit reason will have something that indicates that it was stopped by timeout. And the reason we don't produce a timeout error is that we want the data that's produced so far to be available if you need it. Yeah. And this, we have an option called signal that's really helped to do that. It's meant to help with the cleanup when Quad Shell stops before the child process. So it automatically sends any signal number to that child process that's running. And I think by default it's sigterm to ask it to terminate itself. On Windows we don't have signals, but we allow a special value 9, which is sigkill on the other platforms, that just runs terminate process. It's very, it doesn't allow it to do any cleanup, but it's still something you might want to do. And very often the child process dies on its own because we disconnect, we close our ends of the pipes that it used to communicate with us, so it's not really a problem. Quad-S8 and Quad-CMD allowed us to specify the initial window mode, so hidden, maximized, and I think it did that by a nested write argument, but we use that for something else, so we just moved this into a variant option, and it does exactly the same thing. And this is one of the interesting ones in my opinion. So you can specify what should happen with any of the output streams in the child process. So standard output, standard error, and potentially other than that. You might want to collect the data, you might want to redirect it to a file or do something else. And this is why you do that. And as I said, the default is to collect standard output and redirect standard error to be merged together with that. And there are a bunch of different targets, as we call them. Quite a few of them, actually. So you might say some stream goes to another stream, like we do with standard error, or that it goes to a file that you have tied with quad-entie. It goes to a file that you have just named by some path, or that it goes to an array, and that just means that it will appear in the result. And the data type could be, for example, 83, and you pick it up as bytes. Or you can collect it as an array and specify some text encoding, so as an array of UDF-8 text, and that would be lines of text. Or just, if you just give it an array without an encoding, it will try to guess the encoding based on the data. Or you can redirect to null, which means it disappears. Then we have this special one where you get a callback every time there's some output instead. So that actually allows you to handle the output that's produced while Quad Shell runs. Obviously it requires that I think Quad Shell should run in a different thread so that you have a chance to deal with it. And you specify an encoding or the type of the data, how it should be handled, and pass to the callback function. Or if you don't specify that, it will handle it as lines of text and guess the encoding as well. And so fn is a name of a function, or a name of a function and some left argument. And then the right argument to the callback will be a namespace with some information, and such as the data. And then because it's handled by callback, it won't show up in the result value. And similarly, we have a way to specify where the child process gets its input from, so typically standard input. By default, we only set up standard input, and we set that up so that it doesn't get any data when it tries to read from it. And it's just sort of the same format, a column matrix, and then we have a bunch of different sources, input sources. And as before, you can get input from a file. You can get input from a file by a path or from an array. So you can have some bytes and a type 83 array, and then use that as inputs to the child process. Or use some lines of text with some encoding and default line endings as the input, or with a special line ending. Or you can say that there's no input, that's the default. And then we have this is relatively new addition. I don't know if it's going to stay this way, but we wanted to have an option so that you can provide input while it runs, the similar way we have callbacks to handle the output while it runs. And so we added this token. So anytime you do a quad t put on that same token, it will take whatever you t put to it and add that as additional input to the child process. And then when you're done, you just do a t put without any left argument. And so by default, it always sets up the 3 standard streams if you don't do it explicitly. So standard input comes from nowhere, there's no input. Standard error goes to standard output, and then we collect standard output. And then I have another demo, but that's also screenshots. And I'll show you how to run, just an example, how to run Python 3 using this quad shell. And I'll use some of the variant options. What? Also what? Don't show Brian. No, yeah, that makes sense. Okay, so enable boxing. We're going to run that. So we define our command as this. I use the nested format, so Python 3 with 2 arguments. And I can try running that. And the only thing we get is this Python prompt, and the process probably stopped because there's no input for it to process. So that's not very interesting. So we can give it some input with by saying on stream 0, which is standard input, we want the input to be this array, these 2 lines of text encoded at UCF8. And then that prompt we saw before was pretty annoying, but it turns out that it's actually on standard error, it's not on standard output, and it's only because we merged them. So if we say we don't want to merge them, we want them both as separate arrays, and then run it again, you can see that we now have both stream 1 and 2, and the stream 1 contains the number 8, which is the result of the Python expression. And then standard error contains a bunch of prompts, but you can ignore those. But that's still not very interactive. We had to specify all the input to it up front. And so I can use this token mechanism to provide input as we go. So I say standard input now comes from whatever is t put on that token number. I run quad shell again, but this time in a new thread, as you can see, so that I have a chance to send something to it. So I have this little utility function that just does the tput for me. I have another one that just stops to call tput without any left. And I can send it A is 5, B is 7, A plus B, and then stop, and then I get the result, so 12. Yeah, but that's only the first half of being interactive, really. That's just the input part. So we can say now the output, on standard output, goes to this callback function. And that, just for illustration, I just print out whatever the callback function is getting as JSON so we can see. And I run it again, and I say A is 5, A plus 18. And I get this namespace, and the only really important part is this output that contains the lines of text. And I stop it, and I get another callback. And there's no output, but that's just because the done field, we always get one callback with the done set to 1, so we can do cleanup or whatever we need. And so with this, I can define 2 arrays to contain the standard output and standard error, define some callback function that appends the output to these arrays. The same for standard error. I have this utility to clean up the prompts, but you don't need to worry about that. Then I can say that we use these 2 callbacks and edit these, so we have the windows over there, standard output in the top, and then I run quad shell again. I send it something. I send it B, which is going to give an error, so it shows up in the error because the callback appended it there. And then I get define B and do some stuff, and it shows up in the standard output, and stop. And so really this demo is just, of course, just an example of what you can do, but it wouldn't be that difficult to wrap this up in a sort of make a class, create a new instance of that class, and then send stuff to it. There's this problem with the Python that it doesn't really have that structured format in the REPL, so I'm not sure that you should do this, but maybe other programs have, you can do this exact thing. So to summarize, it's a new system function that will be in version 20. Probably it will look mostly like what I presented, but there's still time to do a bit of changes, of course. And if you disagree with the design, or if you think something is really missing, come see me afterwards. And then if you have questions, now's a good time. Otherwise, you have the feedback.